Alright, my hope is to make this problem fairly snappy, so I'm going to get right into it. And this is the number 7, I believe, from the homework for honors. And it's a cable is pulling upward on an elevator. The elevator and people inside have a combined mass of 700 kilograms. So, looking at this, this is probably going to be important. So there's my mass, 700 kilograms. What tension, so this is my question, what tension is in the cable if the elevator starts to descend with an acceleration of 1.2 meters per second squared? So I drew my elevator and my rope, not really all that interesting. What I'm doing here is I'm going to just make a free body diagram showing the forces that are acting on the elevator. So I've got tension from the rope upwards, and I have force of gravity downwards. And I made gravity the negative direction. I made down the negative direction, which it doesn't really matter. You could do it either way. One thing that you'll notice, though, is that my force of gravity I drew larger than my force of tension. And there's a good reason for that. It's because I'm going down. I'm descending. So when you're standing in the elevator and it just starts to go down, your acceleration is downward. And I know from Newton's second law that the net force is the same as the direction of the acceleration. So looking at this problem, I know that I need my net force to be downwards. I'm going to list some givens now. So I have givens. And there's no real kinematics problem in this one. This is just a pretty straightforward force diagram. So I have, or force problem. So I have a mass, 700 kilograms. I have an acceleration of negative 1.2 meters per second squared. And that's about it. I'm looking for the force of tension. And I have the force of gravity, which is going to be, it is going to be in the negative direction, and it's going to be equal to negative m times g, which I suppose I could go ahead and solve for that, though I probably won't use it right off the bat. So I have negative 700 times 9.8, which gives us something like 690. Sorry, that doesn't make any sense. 6,900 is what I meant to say, but it's actually 6,860 newtons, and it is negative. Okay. So once I've done this, once I've drawn my force diagram, and I've looked at the problem, given the givens, it's really a pretty straightforward situation. So I go ahead and I have sum of forces equals m times a. I know the a, I know the m. Now all I have to do is decide what forces am I adding together. And for that I have the force of tension and the force of gravity. And that's just going to equal m times a. I'm solving for this. I'm looking for what is the force of tension. So I'll have force of tension minus mg, because it's negative from up here, equals m times a. And the last bit is just to do a little bit of rearranging. So I have, make sure that's an equal sign, m times the quantity of a plus g, because I'll move g over and I can pull out the m if I like. And now I'll plug in and I'll solve. And so I am basically just completely ignoring the fact that I solved for gravity earlier. But I do that for a reason, because this is actually a useful formulation of the problem. So I have negative 1.2 plus 9.8, and that equals 8.6 times 700, which is 6,020 newtons. So there's my answer. Now just a little bit of explanation here. Why is this useful? Well, first of all, it's giving me the effectiveness of gravity, essentially, in this situation, or how much we're working against gravity. The acceleration was negative. What that means is that we're actually making the job of the cable easier because we're allowing this to sort of fall. If this was negative 9.8 meters per second squared, that would mean that the elevator is falling at exactly the same acceleration that gravity wants it to fall at, which would indicate that there's zero tension in the cable. On the other hand, if we have an acceleration of 0 here, that indicates that the tension has to support all of the weight of the elevator. And if this is positive, that means that it's actually harder for the elevator. The tension would have to be a larger force than if we were just holding the elevator in place. So this gives us a nice, easy way of looking at problems like this. If you don't see something like this and you're working with elevators, then you probably made a mistake somewhere. And I believe that's it.